Okay, as for our syllabus, so you have one more crypto system in addition to RSA. Previously, we have discussed with the RSA. So after RSA, next crypto system is Robin crypto system. What is this Robin crypto system and how it could be worked out in terms of providing security to the people while it is being used? Let us have a look here. And it was introduced by Michael O. Robin in 1979. Okay, it is also based on RSA only, but minute changes are there in terms of considering RSA here. Okay, and it is also another variation or version of RSA crypto system, and RSA is always trying to explore with exponentiation. Exponentiation in the sense some you call some ciphertext will be equal to plain text something power e modulo division of so n, something like this. Something like this will be in terms of taking the specification here as far as the RSA is concerned. So this is called as exponentiation. So power something, then that is called as exponentiation. Whereas if you go ahead with Rabin is based on quadratic. I hope that everybody have understand what is quadratic. Quadratic in the sense, so square root of. Okay, it has been taken in terms of quadratic outputs must be there with us. So plus or minus something like that. So here it is being taken. So square root of kind of so congruences which could be taken into consideration of so this Robin crypto systems. Okay, that is the basic difference between these two. And one more very important difference between these two is in RSA, you have to find the value, or you have to take, or you have to consider the value of E and the value of D in RSA. Whereas here, these two values are fixed. These two values are fixed. One is power 2, so P power E, that is P square. And second one is while decryption, so it could be square root of something, half in the sense, so anything, let me say some ciphertext 1 by 2. If you write something like this, it's also written something like this as a square root of some C. So that is why it is a quadratic congruency. Okay, so these two are fixed. So this could be used to create in RSA. This could be used to create encryption, and this could be used to create. This could be used to get the data back in decryption. So here in encryption, it is taken. So ciphertext will be equal to so plain text square. Of course, modulus something will be there. We will discuss later. So plain text. Plain text power 2 will be taken into consideration in Robin crypto systems, whereas in decryption, so some plain text while getting back this plain text, so it could be taken so square root of C. So square root of C in the sense it is obviously written something like this here. Okay, so that is why it is a quadratic congruence. Okay, so these two are fixed. You have to understand these two. Then followed by, so as I said just before, so ciphertext will be during encryption process, the value could be seems like this. Okay, so what is the value of n? Let us understand after some time. Next slide, we do have the value of n here. So P square, P capital P in the sense that is plain text. So C is congruently equal to P square modulo division of n, where it is being considered as encryption, whereas in decryption, so while getting back the plain text from the ciphertext, you are supposed to take so P congruently equal to C power 1 by 2 modular division of n here. Obviously, if you take anything in terms of a square root of something C, the roots of this particular value could be always available in terms of plus or minus. So totally two different types of roots will be there for us. Okay, let us consider what are those roots and how this could be taken into consideration. Okay, let us have a look here. So this is encryption, and encryption formula is this one, and the decryption formula could be this one here. You need to remember these two. And then followed by here, public key of this Rabin crypto system will be N. Public key of this Rabin crypto system will be N. And the private key will be P and Q. What are these P and Q? Let us have a discussion. Okay, after some time, probably within a couple of minutes, we will have the discussion regarding to P and Q here. So public key will be thereby, the public key will be so considered as E comma N in RSA. There is a tuple which could be taken into consideration by the public key, that is E comma N, whereas the private key will be D comma N. It's also a tuple. So thereby you have been identified some phi of N. After taking N, phi of N also be taken into consideration. But here such kind of operations could not be there into consideration by this particular Rabin crypto system. However, so Rabin crypto system could be taken the public key as N, whereas private key will be a tuple. Tuple in the sense two values. So namely P and Q. Okay, and then so if you know about N, yes, N will be given by the person who is interested to accept some kind of messages from people. So he may be given this particular N to everybody, so that everybody they have their own message. Let me say some X is having so X is as generating so the public key, that is N. It has been placed onto the insecure channel. Let me say that is internet, and Y will be taken this particular public key. Actually, Y is not the actual person who is communicate with the X, and Z is the actual person who is able to communicate with the X actually. So Z can be taken, Z can be receives this particular key, and Y also receives the same key here. He may be perform, so he may be let me say create the ciphertext by Y. He may be also create ciphertext. So preparation of a ciphertext will be very easy by any number of people, but it is somewhat so difficult to decrypt. Decryption can be done by only X as per this particular example, because X has prepared this public key and has been put onto the insecure channel, that is internet. So therefore, only X can be decrypt the message, where encryption can be done by huge number of people. Okay, so that is the specialty of Rabin crypto systems. And then followed by so P and Q are unknown. So this P and Q are unknown to anybody, so that decryption will be somewhat infeasible. It is not feasible to the person, because here we are trying to perform some integer operations. Okay, integer arithmetic operations could be done here, so that could be somewhat difficult to do decrypt the message by the intruder or hacker. Okay, and here we need to understand, so selection of a P and Q must be, there is a restriction to be selection. Whereas in RSA, so P will be selected at our own and Q will be selected at our own. Okay, there might not have any restrictions out there. P and Q are very large prime numbers, and these large prime numbers can be selected by you without having any restriction, any hesitation. Whereas in Rabin, yes, there are some restrictions. Only one restriction is there. That restriction will be P modulus of 4 must be equal to 3. So it must be, you must be select in such a form. As well, Q modulus of 4 must be, so again 3. That is 4 into K, so plus 3 form. 4 into K plus 3 form. In this particular form, you have to make your selection. So if you do not understand this particular equation, what does it mean? So if you select any prime number, modulo division of 4 must be gives the remainder as 3. Modulo division of 4 must be gives the remainder as 3. And Q also be selected such that Q modulus 4 must be gives the remainder as 3 here. this is the specific restriction while we are going to select the values of P and Q here. And of course, already we have given one statement here. It is another variation of RSA. It is another variation of RSA here. In RSA, you are expected to select P and Q are two different types of so large prime numbers. And further, you may be identify n will be equal to P minus 1 and Q minus 1, P minus 1 into Q minus 1, then followed by P of n, then followed by you are expected to identify or you are expected to take one value that is E. E must be gets identified and D must gets identified. Then you have to prepare public key and private key. Hope that you do remember the steps. Steps are, so let me take another slide and I'll explain. In RSA, steps will be, first and foremost step will be, you are expected to select two different types of, so very huge prime numbers. They will be P and Q. During this selection, there is no restriction. There is no restriction here. Second thing will be, you need to identify n will be equal to, so P into Q. This is the way you have to prepare the n value. And third one is, you need to identify P of n. P of n in the sense P minus 1 into Q minus 1. P minus 1, so into, so Q minus 1. So if you are performing this particular operation Q minus 1, this particular operation, then obviously you have to have the P of n. And fourth one, so you need to select the E, which could be ranges from 1 to, so P of n. 1 to P of n, you have to select one particular value such that so E comma, so phi of n, GCD of, sorry, P of n here. So GCD of, GCD of E comma phi of n must be equal to 1. You must be select by following this particular equality. And then fifth one is also you have to select one more integer, that is D, which could be ranges from 1 to, so phi of n again. And here also you have to take a GCD of, so GCD of, so D comma phi of n must be equal to 1 here. So phi of n and D must be co-primes. In such a way you have to select. After selection, moreover, D must be, so additive inverse of E. Additive inverse of E. In this particular form, you have to select D here. After selection of these, what you are supposed to do, so you have to publish the public key and you have to keep the private key with you. Public key will be, sixth operation will be, so public key must be equal to E comma n. So this is the public key tuple. And the seventh one is private key, PK. Private key will be equal to D comma n. So private key will be there with you, and the public key you have to forward to, so forward through the internet, so that the people will be received and they have to prepare their ciphertext. In this way, these are the 7 steps which are available with RSA. And we have to consider that Rabin also, so one of the variety of this RSA, so that it could also be taken in the similar fashion. So the fashion will be, let us examine. So here, first step in Rabin also same. Step number 1 will be, so you have to select the values of P and Q. It is also same, but there is a restriction how you have to select here, in the sense P modulus of, let me write MOD, modulus of some 4 must be equal to 3. It is the first form you have to consider. And so Q modulus of, this is Q actually not 9, Q modulus of, so 4 will be equal to 3. And then P must not be equal to Q. P must not be equal to Q. By following these restrictions, you have to select P and Q. By following these restrictions, you have to select P and Q. This is what I'm talking about, Rabin. RABN, Rabin Cryptosystem. I'm talking about this one right now. Then followed by second step might be, first step must be you have to follow these restrictions. Second step must be you have to find the value of n. A value of n is of course same as it is in terms of so RSA only, that is p into q only. Immediately you have to you never consider what is third step is eliminated from Rabin, and the fourth step is eliminated because step number 4 will be a constant value, that is 2, and the fifth step also eliminated here. So step number 5 will be deduced from RSA is D also constant value, that is 1 by 2 already we have taken. So this is also eliminated. Now time to define what is public key. So step number 3 will be public key PU. Public key will be equal to n, and so time to define. So the private key, that is PK. PK will be equal to, it is a group of values or tuple of values. So P comma so Q. These are the two values. This is public key. You have to place onto internet so that everybody can be taken that particular value and prepare ciphertext. Okay. So here you need to remember, note will be there here. That note will be, so you have to always remember E must be equal to 2 as far as Robin, and D must be equal to 1 by 2. These are the two constants, and there is no necessity to identify what is phi of n, and these things are not supposed to be taken into consideration. So look at this, everything is similar, but some number of operations will be eliminated from Rabin while we have to consider about this RSA. Okay, so these are the specific operations what we are supposed to take into consideration in terms of Rabin while we compare with RSA. Okay, now let us see. Now, so what are the specifications you need to consider here? Let me erase everything because some slide is there here. So let me erase everything. So if anybody interested to write, yes, you could write everything. There is no problem for me. Yes, you could write. You could write if you want to write this one. Otherwise, you maybe follow this particular video once again. So I'll send the link to you. Then you have to follow. Okay. Then followed by. So what exactly you are trying to do? How the situation could be done here? Bob wants to prepare a public key, and based on the Bob's public key, Alice wants to prepare some kind of plain text and prepare some ciphertext, and that ciphertext will be received by Bob, and he must do, or he must decrypt that particular so ciphertext into plain text by using his own private keys. How it could be? Let us have a look here. Bob has been prepared the key generation. He had to select P and Q. So P and Q, already I have given some restrictions over here. So P modulus of 4 must be equal to 3, and the Q modulus of 4 must be equal to 3. These two restrictions must be always follow. Then only you are eligible to consider the values of P and Q. After taking that one, that restrictions and everything, so you have to identify n. Now you have to send that n to public. Okay, that n to what you call. So this will be, so internet unsecured channel. We have to place out there. After that, that public, that P has been received by so Alice, and she has prepared the plain text. So he has considered some message that is a plain text message, that is P, capital P, and C will be equal to P square modulo division of n. So with this one as prepared. Okay, so this encryption process must be happen in terms of so Z star X only. X in the sense the value of n here. Whatever the value n we have to consider here, that is the value of n here. You have to take into consideration with this one only. And after preparation of this C, I mean ciphertext, so this value could be sent to Bob. Okay, so Bob will be receive that one, and Bob does have P and Q as a private key. Using that particular private key, So using quadratic residues, we will come across that what is the residue, how this could be done. I'd like to explain everything using one example. But don't worry. So using quadratic residues, so he was identified, and so he got exactly 4 different types of answers. Because we do have two different types of inputs are there as far as private key is concerned. So for P, so plus or minus, so C or plain text P will be come across here. So not exactly C, it is being identified only plain text only. Let me write in terms of plus or minus. So let me take M, which is based on this private key P, and again plus or minus. Plain text back, message back, that is which is based on so the Q. Finally, you could get minus M1, for example, plus M1, sorry, M2. These two are related to so the key, private key P. So minus M3, so and plus M3. These two are M4, sorry, M4. These two are related to so Q here. Okay, there are some certain combinations are available. I'll let you know what are the combinations after some time. Okay. So based on this quadratic residues and getting 4 different types of outputs will be there. So these 4 outputs will be decided which output will be correct, and the remaining things will be discarded. Okay, however, let me explain this one. By taking this one, he maybe get so the plain text back, and during this particular point, intruder. What exactly intruder can be done here in the sense, he's always trying to take the ciphertext based on the knowledge. What knowledge he does? He does have only N with him, because N is the public key who was generated by Bob and can be sent onto the unsecured channel, that is internet. So intruder does have only N, and intruder does also have ciphertext with him. So he does have ciphertext and he does have N with him. And he is also know about the preparation of a ciphertext, that is a plain text square modulo division of N. It is the way of encryption, and he's also have some kind of information that so M1, M2, M3, and M4. How could he prepare M1, M2, M3, M4? Because everything is known, everything is public. But here the problem is, so M1, M2 will be combination of P, M2, M3, M3, M4 will be combination of Q. So identification of these two will be somewhat difficult. Identification of P and Q are very, very difficult by taking only the value of N here. So that is why it is infeasible. It is infeasible. Normally P will be equal to square root of C modulo division of N. It is also there with him. It is also there with him because this algorithm is public. It is available for everybody. But so this could be done. So 4 different kinds of answers will be there with us. So how could you decide what is P and what is Q? So it could be very, very, very difficult to understand. So that is why which is infeasible. Okay, intruder cannot be so get back the plain text very easily. So after taking huge amount of time, then he will get, but it is very, very infeasible. Okay. Then based on this one, let us have a look here. Rabin key generation, how this could be happen. Some algorithms can be taken into consideration. So he must be choose 2 different types of values, that is P and Q, are which are very, very large prime values. And he must be satisfied with 4K plus 3. 4K plus 3, already I have explained to you what do you mean by 4K plus 3 here in the sense. So P modulo division of P modulus of so 4 must be equal to 3. This is first one. And the Q modulo division of so 4 must be equal to so 3. So if this restriction will be gets followed, and of course one more restriction, P should not be equal to Q. If these 3 restrictions will be followed, then you have to move further. Go further. Okay. Otherwise, you shall not. You could not go further. You just stop your work if these 3 restrictions could not be fixed. Afterwards, so we have to identify n equal to p into q. After n equal to p into q, so he may be announced that yes, n will be the public key and which will be announced to everyone. My public key is n. So this is the way of so reducing so this key generation. Of course, private key will be with himself only. Public key can be after announcing this public key. Obviously, so private key will be so there with him, and then we have to return what is the public key and what is the private key. Both will be returned, and both will be so seeking in the same place. So public key will be placed onto the insecure channel. Private key will be always with him. This is the way of generating the key using Rabin cryptosystem. And how encryption will be, already I have given, encryption will be done. So it could be taken two inputs. One is plain text, whatever the plain text you wanted to take into consideration, capital P. So to distinguish the P and the key values, here in P and Q in private key, so P will be one prime key. So to distinguish these two, I have to consider capital key as a plain text, and so small p will be private key, one of the parts of private key. So C will be equal to P square modulus of n, and has been prepared, and whatever the output after taking this particular value, whatever the output, that output will be returned. That's all. Very simple, very, very simple encryption algorithm. Two simple encryption algorithm by Rabin. While doing the process with decryption, here it could be. Decryption could be taken, so three inputs or three parameters. So private key P and Q followed by the ciphertext what was generated by Alice to Bob. What exactly he will be doing? So he will be perform. So A1 will be equal to plus C power P plus 1 divided by 4 modulo division of P. This is first one. Similarly, minus C power P plus 1 divided by 4 modulo division P. And A3 will be this one, and A4 will be this one. So here, let us consider this is A1, this is A1, okay, this is A2, okay. Let me make it as, so for the time being, I'd like to consider this is B1, and let me make it as this is B2. Because A1 is positive, A2 will be negative, B1 is positive, B2 will be negative. If you take into consideration by making them into different combinations, so A1 is positive, comma B1 also positive. Okay, positive, comma positive. Then followed by A1 is positive, so comma B2 is negative, positive, negative. This is one combination, one set of combination. Second set of combination is A2 is negative, so B1 is positive. Okay, then A2 is negative and B2 also negative. This is another combination. Let me say plus and plus, one combination, and then followed by plus minus, another combination. So minus plus, another combination, minus minus. So that this is one root, second root, third root, and fourth root. Totally 4 roots are there here. Based on this one, we have to generate it here. Okay, after getting these values, so we have to follow the Chinese remainder problem. Chinese remainder theorem could be gets operated here. So the Chinese remainder theorem will be, already I have told you, A1 is this one, B1 is this one. So the combinations which could be provided by P will be A1 comma, so A2. Whereas the combinations which will be done by Q will be B1 comma, so B2. So that is the point here. Okay. So A1, B1 followed by P and Q. A1, B1 followed by so P and Q. This is first one, and second one will be so P2 will be again A1, B2. So whatever the combination I have given here, and whatever the combination I have given here, that is A2, B1 followed by the private key, and so on and so forth. Like this, we have to solve this particular problem for 4 times using Chinese remainder theorem. Already Chinese remainder theorem has been explained to you. So here we have got P1, P2, P3, P4. Otherwise M1, M2, M3, M4. This is plain text which is getting back. Out of this, user has decided which plain text is correct. User in the sense the receiver. Bob has to decide that P1 is correct, or P2 is correct, or P3 is correct. Which is correct has been decided by so the receiver. Okay, so that is what the point. That is the Rabin crypto system decryption operation. This way decryption operation could be done here. Let us go ahead and let us see some example how this could be. Like let us consider Alice and Bob. Bob wants to prepare a key. I mean, key generation will be took place something like this: P equal to 11 and Q equal to 7. P modulus of 4. So 11 modulus of 4 will be equal to 3. Similarly, Q modulus of 4, that is 7 modulus of 4, also equal to 3 here. Therefore, we have to identify. So whatever the restriction which has been enforced by Rabin crypto system has been passed by, so this P and Q, that is 11 and 7, so that N will be identified, 77. After that, the public key will be 77. The 77 has been placed to the what is it insecure channel, and private key will be always with him. That is 11 comma 7 will be always with Bob only. Now, so plain text. Alice wants to prepare. Alice wants to communicate with the Bob by taking one plain text, that is 5. Okay, she wanted to communicate with. So she wanted to send some signal as 5 to Bob here. The equivalent binary value will be equal to for 101. What she did here is the same 101 will be replicated for several times. So here twice it has been replicated. Okay, if it is replicated for twice, 101, 101. So appended, so side by side, which will be leads you 45. Now the plain text will be 45 here. Now the plain text will be 45. Initially he was considered as 5. So she has considered as 5. But right now, because of this replication, so 45 will be the plain text. Based on this one, she has prepared encryption something like this. 45 square modular division of 77 will gives you 23. Now the ciphertext will be 23. 23 has been sent to Bob. Bob has received 23, and what he did here is, first one is 23 cube. So modular division of why this one 23 cube here in the sense. So here, so C power. Okay, let me write somewhere else. Okay, C power. So P plus 1 divided by what is that, 2 divided by 2 divided by 4 divided by 4 divided by 4. So P plus 1 in the sense that is P value is 11. 11 plus 1, that is that will be equal to 12. 12 divided by 4 in the sense it could be equal to 3. So that is why we have mentioned as 3 here. 23 cube modular division of 11 will be gives you. Let me show you how this could be. It is correct or not. Let us see. So let us see by using calculator. 23 into 23 into 23. So modulo division of 11. Modulo division of 11 will be equal to, yes, it is 1. So because we have two different types of answers, one root will be positive and the second root will be negative. So that we have taken second root also negative 1. And third one is, second one is, Q plus 1, C power Q plus 1 divided by 4. So something like this modular division of Q has been operated here. So 7 plus 1, so that is 8 divided by 4 will be equal to 2. So that is why we have written square here. That is the meaning here. Okay, 23, 23. Let us examine 23 into 23, modular division of 7. Modular division of 7 will be equal to 4. Yes, plus positive 4 and negative 4 has been prepared. Then followed by, after taking this one, he was operated with Chinese remainder theorem. After taking Chinese remainder theorem, he was 1, 4, 11, 7. 11 in the sense this is P and this is Q. This will be B1 and this one be A1. Okay, A1, B1, PQ. A1 is positive 1, B1 is positive 4, and this one he got this particular value. If you run this particular operation, then you maybe get 67 as answer. So like this, you maybe get 10 is the next one, and 32 is the next one, and 45 is the last one. And if you identify the binary equivalent values of this particular thing, look at this. The binary equivalent value is 1000111 base 2, and then this one is this one, and also this one, and finally 101101. So it has been replicated, same kind of texture here, same kind of pattern here. So therefore M4 does have the replication bits. So therefore, which is the plain text. The plain text is after eliminating one group of replicating values, then the 101 is actual value, which is 5. In this way you have to identify. If it is not the case, if replication could not be done, if you refer some textbooks, this replication is not given. Not some textbooks, almost all textbooks, it has not been given here. So if a replication could not be there, you have to decide which is the actual plain text among these four. So therefore, that could be somewhat problem. So to avoid such kind of confusion, so take one plain text something like this and replicate the bits in terms of this one, and compute in terms of uh, decimal system, then follow the same procedure. This is the way you have to identify. Okay, so this is the way. If the element is not there with us, this is the way. In this way, you have to identify and get the operations of Rabin cryptosystems. So when this question could be asked to you, then immediately you have to make some kind of so distinguish between RSA and Rabin first, then followed by everything will be gets explained. Okay. So this is what for today's class. We'll go ahead and look into the matter by tomorrow. Okay. Tomorrow it is actually there with you, so I'll explain after some time about this particular thing. This is what the today's class.